doing this brain-busting challenge lead us off?
Hello, we're Team Dinojerks, and we worked on the challenge to visualize dinosaur brains. And the problem for the museum here is that they have tons and tons and tons of data, but they don't really have an efficient way or an automated way to sift through that. And on top of that, to make it work, the programs that they use here are incredibly expensive. So it's really hard for people, thank you, for people to actually access this data and parse it and work with it on the grand scale that actually is available. So what we set out to do was, since some of the teams actually focused on getting the brains out of these skulls and visualizing them, we thought about if there are ways to visualize the skull quickly and kind of make try to emulate the software that costs, I think $6,000 or $9,000, and be able to target different bone densities based on CT scans that are available here, and show selections in 2D that reflect that bone density so we can actually show the skull. On top of that, we just wanted to make a nice visualization. And then in the end, also hopefully export that data so it can be reused. And Charlie here is going to walk you through what we made.
All right, this is a standalone app that we made in C++ in a framework called Cinder. And it's downloadable. It can be for Mac or PC. And so here we are loading up a folder full of these TIFF files, which are all individual CT scans. And now you can see we've loaded 196 TIFF files, and we're scrolling through them. So you've seen this up in the beginning. And these, the red outlines indicate that this is something that we're currently capturing. So now we flipped on the raw CT, and you can see what the raw CT data actually looks like. So anything that's in red is something that we've selected and want to be part of our mesh. So we can also select different values of grays. So this is letting us select the bone density. So white might be very dense, and black's very non-dense at all. So we're selecting the medium density, and we're upping the tolerance because there might be a little variation in the bone density. And once we do this, we can go to a 3D mode. And this is a fully rendered point cloud. This is about 150,000 points of data for this. And we can probably do up to about 600,000 without breaking a sweat. And this is also exportable. So Ben just clicked export here, and it has exported all of the data into a giant file that we can then take to another program to both visualize and then clean up or to generate meshes. So we're going to take it here, and we're going to drop it in Mesh Lab off the bottom of the screen. And there we go, exported live from our application. And so all within the same app, you can pick what you want, visualize it, and export it.
Awesome.
And then, so this is another one. This is another bird that we did. Pretty cool. And so up next, these are challenges that we want to take on. We want to be able to export a full mesh app with normals and everything right from our application. We feel like we could do that. Sometimes older fossils have sediment that's really noisy, and if we could do some filters for that and get some noisier fossils out, these are pretty clean as far as CT scans go, so we understand. Speed optimization, make it go faster, load faster. And finally, we're artists, so we want to make cool things for people to play with. We want people to use these things creatively and load them into other applications like everyone's been doing here today, which is amazing. And that's about it. Thank you very much.